Glad I had a short presentation this morning, and this is along similar lines as far as talking about Open Compute, CG Open Rack 19, Cord, and integration services. So basically, we'll start with an introduction here. We've all been talking about this, and it's been very clear as far as the benefits of an open model. And what we're talking about here is within OCP, there is, of course, the Open Rack requirements, the standards that we've all been looking at. But as you're aware, and if you were here for Jeff's presentation, Radisys developed and got approved the CG Open Rack 19 specification. And so some of the hardware that I'll be showing is what Radisys has as far as CG Open Rack 19 hardware. And of course, there's other vendors as well within the ecosystem that have other components that are compatible with that. But in any case, in a broad sense, both of those are very similar. They are both within the umbrella of Open Compute. They're both share a lot of power distribution, rack systems, plug and play, et cetera. So the benefits here are, of course, the customer gets to break that proprietary box and gain control of their system. They also break all these connections between the hardware and the software running on it. And of course, your development then can be made up of building blocks that are available for both the hardware and the software. And that gives you that flexibility, ends up giving you lower system costs and more efficiency typically, and scalability, et cetera, including, in our case, and what we're focused on a lot, is lower operating costs. So specifically, when we generated the CG Open Rack 19 specification, we're looking at requirements that are more specific to the customers that we've seen. Radisys has more of a telecom background. A lot of our customers are telcos, tier 2, tier 1s, and they, as well as Radisys, were excited about Open Rack and what it makes available. But we also noticed that there were some things that made it difficult for us to use. For example, there's issues possibly with emission control that Facebook doesn't have. In fact, if you look at Facebook's focus on by the acre systems, there's a lot of things that they can do that an operator can't do, or that somebody operating a medium-sized data center can't do. And so we looked at, is there a way to take what's great about Open Rack and adapt it to the telcos and the carrier grade operators. And so you'll see that there's a lot in similarity here and some specific things that are different. But in any case, we started out with the project back in 2014 with prototypes, and we ended up making a first generation, second generation. We shipped material, et cetera. In 2017, we went through the process of getting approval for the CG Open Rack 19 spec that's been distributed. In fact, it's gone through one revision since. This is an in-production system. Radisys has shipped and installed in 6 data centers. We've shipped hundreds of racks. We've within those have shipped thousands of sleds of different types. And all of those are actively running, carrying customer traffic. So these systems have been up and running for years. So I don't want you to get the idea that this is new or it's undeveloped. This has been running. The spec itself, of course, these are just some snippets out of the spec, but the spec defines the interface between a plug-in sled and a rack. So it doesn't tell you how to build a rack or what the rack has to do. It doesn't tell you what goes on specifically inside a sled, but it tells you how those two mate together. I think on the lower right, you can see the back of a sled. And so the power connection is the same power connection that's in OpenRack. That we share. It's a 12-volt system, the same. But what we did was, in the lower left of the back of the sled, there's an optical connection that's blind mate. And that has many lanes of fiber connection that go to the switches at the top of rack. Those include management networks as well as data plane networks. So one difference here is that when you plug this in, it makes not only a power connection, but it makes all the data connections automatically. And so what that allows you to do, for example, is build a rack, predefine a rack, test a rack, ship it. It has all the connections in it. And now when you install a sled, all the connections are made and it runs. If you want to, for example, replace a sled, you don't disconnect any cables. You just grab the sled, pull it out within a second, replace it with another sled. All the connections are made again, and it's up and running. With another, another system, maybe you have to disconnect cables from the sled. You have to reconnect those cables. You have to get things out of the way, et cetera. This is, from the front of the rack, there's no cable showing. Another thing that I wanted to kind of cover as far as CG OpenRack 19 in the ecosystem, just this would give you an idea of what's actually available today. It's, I think you can see over at the AD-Link booth, you can see a smaller rack. This is the 16U rack from Radisys. And then additionally, you can see some sleds that go into that rack. But there are many, many choices here. And if you sort of look, there's quite a lot. For example, these racks come in different widths, different colors, different depths, different number of shelves, different numbers of switches, different power configurations. The power can be 3-phase AC, single-phase AC, minus 48 volts, plus 300 volts. There's basically every configuration for every geo available. We've shipped these out. This is not hypothetical. The racks are available in a half width or a full width. The full width is set up so that certain form factors, like 3.5-inch drives, fit very well in a full form factor, and you get a much higher density. It allows us, for example, to have a storage sled with 24 SAS drives and a capacity of 288 terabyte within that replaceable sled. It also, there's the network interface, as I mentioned, can be 10 gigabit, 40 gigabit, 50 gigabit, 100 gigabit. We've done all those. The ecosystem right now, what we're focusing on is 4 members of the ecosystem. There's Radisys ourselves, of course. There's Artisan that has a sled that you can see over at the AD-Link booth. There's AD-Link themselves with a compute sled. And there's Pentair that Radisys has done a lot of work with as far as developing the rack and some of the sleds. So you're able to, within a CG OpenRack system, buy products and competing products from several companies. And there are other companies as well working on this. This is just 4 that I've mentioned. I want to mention some of the benefits. Now, some benefits that I'm listing there are shared by OpenRack, but some of them are not. Some of them are specific to CG OpenRack 19. The chart on the side, the right side, was actually done by SK Telecom, and it was shown at an OCP meeting. I just wanted to bring it up because it demonstrates some benefit, for example, of centralizing the power conversion instead of having it on a per sled basis or a per server basis. But some of these that I'll mention, of course, by having cooling in each of the installed sleds, the cooling is controlled on a sled-by-sled basis. It allows you to have a heterogeneous configuration. So instead of, for example, having a rack that maybe Facebook would have where everything in the rack is identical, we're now talking about a smaller configuration where the racks or the sleds could be quite different. And you could upgrade as you go. So you move from, for example, a low power sled to a high power sled. There's no other change to the rack. Each sled is independent in that case. Now what we did with CG OpenRack 19 was we set the sled height to 2U, and that's to RU, not to OU, so that we could actually use 80mm fans in the back. And what that does is it gives us more cooling efficiency. We actually consume less power with an 80mm fan. Secondly, it's a lot quieter. We had pushback from our customers that they weren't happy with the whining that are coming out of some of the sleds. So the whole system is actually quieter, it sounds better, and it saves power. We also enclose the sled so that it contains EMI within the sled itself. And that's obviously important for our customers. One of the big things that I mentioned is the blind mate optical interconnect. The sleds have that connection in the back, and those can be redefined, they can be reconfigured, but nonetheless, what some people like is that they can completely configure the rack connectivity, the mapping between the sleds and the switches, and that doesn't change even when you change sleds, when you remove or replace sleds. It also keeps the port to the switch port to sled port connectivity mapping the same. This is an adapted sled that, an adapted chart that Artisan made that I've put in here, basically showing some differences. These are obviously picked up by us as far as the benefits here, but another thing that our customers wanted to be able to do was be able to meet NEBs, be able to meet some high temperature requirements. We have customers, for example, in Japan that want seismic. And so from the ground up, CG OpenRack 19 and the racks that were built for that is built to support NEBs, built to support seismic requirements. And it's also, like I said, built to support an instant tilt-up install with these racks. So I'll just bring up some examples. Now, I talked about some sleds that are already available, that we've had them available and shown them at OCP summits before. We have several compute sleds, both Haswell, Broadwell, Skylake compute sleds. Each of these sleds, 2U high, half width, have 2 servers in them, so 4 sockets per. These are very configurable as far as the storage that they have, the connectivity they have. But I won't go into that now. You can see them over there as well. Additionally, we have storage sleds that have much larger storage capacity. What I'm going to talk about here is, for example, a new storage sled that we've come out with, which has 24 drives in a modular configuration and a Skylake server. So this sled, as you can see, is built up of drives along the side. There's, of course, 12 on each side. These are in carriers that can basically be pulled out as a group. The Skylake server is managing these sleds through 12 gigabit per second SAS. And additionally, the sled has 25 gig links to the top of rack switches. There are additional drives as well that are related to, say, for example, you have a Ceph configuration and you need journal drives, or you want cache drives. There's space for those as well. So I'm not going through all the lines on the side, but you can see that there's a lot of configurability as far as a lot of capacity here. This is a block diagram of that sled. And you can see we're using, essentially, one nice thing about CG OpenRack 19 is we're able to use standard, off-the-shelf, or custom half SSI or half width server cards in here. So it allows you, for example, let's say in this particular case it's a Skylake, but you've decided that what we really need is an ARM processor here to control it. There's lots of people that believe an ARM processor would be better for storage. It's really no problem as far as that will fit in the sled and still give you that configuration. So one thing that Radisys does is set up these racks the way that the customers see them as the highest performance. Now, additionally, another interesting rack that I want to talk about is what I call the expansion sled, or sorry, the expansion sled. This is basically a server at the bottom of the sled, but above, in this image, there's actually 4 DSP cards that are installed in PCI Express slots to the server. So in this case, these are TI DSPs. But what this obviously allows you to do is to do processing offload from the Skylake server below. And this as well is a Skylake server with 25 gig interfaces to the switches at the top of the rack. This is a half-width sled. This is something that Radisys uses as part of our media products. Radisys has a lot of software and hardware media products. And what we've done is this is a DSP-focused sled. It used to be that what we had was proprietary hardware with processors and DSPs, and now we can go into a standard configuration. It's been very successful for us. Now, when we look at the expansion sled, the idea of having a server with plug-in PCI cards, standard off-the-shelf cards, some ideas that have come to mind recently that we're working with are either using a DSP card like the Advantech or going with GPU cards. For example, GPU cards, Tesla cards from NVIDIA or from Intel. Those cards, for example, the GPU cards are full length, full height, double width cards, and we're able to fit those within the same expansion sled. Let me see, this sled is some other views of the DSP version with 4 DSP cards. So those are also full length, full height, but they're a single width card. But this is a sled that's actually over at, we're showing our stuff over at the AD-Link booth. And so you can see this sled over there. This is the similar block diagram for that card. And you can see what's stayed the same and what's changed. In this case, we have the server board. We have riser cards on the left, which then are taking the PCI Express cards in them, as well as some additional SSDs that are used, of course, for processing. This is an image. This is in process right now, this sled. But basically, there's the 2 GPU cards plugged in there. And it's the same configuration or same concept as the DSP, but we're able to use that for basically any PCI Express plug-in card. In this particular case, there's a lot of power consumption. The sleds are designed to go up to 1 kilowatt per sled power consumption. And the rack is designed to support a full rack of 1 kilowatt. That would be 32 sleds up to 64 servers in a rack. So the difference with this configuration is that you can see on the left, we changed the 4 DSPs to 2 GPU cards, but it's everything else is the same. So I'm going to switch gears here, but that's just a flavor of the flexibility, what's available out there as far as plug-in cards beyond the standard sleds that we talk about oftentimes as compute-focused or storage-focused sleds. So as you're looking at right now Radisys is very much involved in cord projects. We're involved in M-cord, R-cord. We've actually shipped quite a few proof of concept systems that are based on our 16U rack. The 16U rack is easier to move. People don't need to fill a rack for a POC. And within that rack, we've got, of course, switches. We've got compute and storage sled. We've got the power conversion and any kind of optical termination as well. But anyway, when you look at this, this is a great vehicle for R-cord and M-cord, both as well as POCs and small configurations, as well as, of course, you could plan on going to a large rack or several racks for larger cord systems. This spec can be used for a wide range of form factors, and it can be scaled up and down. Let's see, I'm trying to get my connection here. Right now, Radisys has been a lot more involved with shipping POCs related to R-cord right now, because R-cord is better defined, it's more active, it's sort of further along. We are working with M-cord, but M-cord is still in process, so we're using some of these POCs for that, but the truth is that that's a little bit later in development, and we're working through that. Hope I showed the right slide there. So I want to talk to you now a little bit about Radisys integration services, because of course we talked about the hardware platform, talked about some applications related to cord, and Radisys is definitely playing in the cord space and providing hardware as well as software services within the R-cord and M-cord. But since OCP is an open standard, and since there's many available building blocks for this, it also means that you need to pull together the hardware and software building blocks to make a complete system. As far as we see it, somebody has to pull this together, whether it's a third-party integrator or whether it's the service provider, somebody's got to do it. And it's the value of OCP to make off-the-shelf building blocks available, but now you need to pull it together, and once it's together, somebody has to maintain it going forward. So what's really needed is a way to bring OCP to full deployment, including the integration, and that's what Radisys does. Radisys provides that system architecture, the system planning, the system integration, the testing, the support. On the right side, you can see some of the things that Radisys does. For example, open source software continues to evolve. Every update is a costly enterprise. And so we work with our customers in a very fast way to get the software into the network. Another example is Datacenter turnup. I think you saw, if you were here for the earlier one, that where Jeff was talking about system install and how it went from months to days. That was our system, and that was our system being involved or being installed. And that was a big improvement for the customer. They essentially take delivery, systems, the whole rack gets unboxed, installed, it's up and running within a couple of days. Those days are pretty much just the verification process. So in summary, this function, there's somebody that has to pull this together. Somebody has to do this, and Radisys can help accelerate the process of deployment and after deployment. So just a little bit of fleshing that out. As you go through the process, there's many steps, and of course you can do this different ways, but we really think you start with the proof of concept. You've got to design, to plan a proof of concept based on some options that you think you have, but you're not sure which really works together. And then you've got to take it to customization. The software is not plug and play at this point. There's a lot of choices, but it's not plug and play. But that's the beauty of open software. You get to do what you want. Now you need to figure out what it is you want and how it goes together. So you also have to figure out how to manage it, how you're going to install it, and how you're going to handle replacements, et cetera. So with testing and automation, you ensure that the system is fully tested, that it's hardened for deployment. And then you need a support structure to work with the system in case that there's fixes or replacement, et cetera. So that all comes under the umbrella of Radisys support services. Sometimes in the beginning, you don't know what you need. You don't know what the gaps are. You don't know what replacement you're going to use, and you don't know what's available. So you want to develop prototypes, and you want to execute the proof of concept quickly because you don't want to spend a lot of time on that. We want to evaluate the open source software and the building blocks and put them all together. We want to know how well the software meets our operational needs and business needs. Keep in mind that there has to be a business case. The target is to see if the hardware building blocks, whether it's OCP or not, I mean, you still have to decide that as well, and the software building blocks, which might include some proprietary or custom work, are going to do what you need to do as you migrate your system. It gets you down to a few options, but you still need more work after you've worked through those options. Oops. Sorry. We'd also, basically what we come down to is these 4 critical steps that have to be done as part of system integration. You have the software, you have the hardware, you know what you want to, you think you know what you want to put the system together, but now you need to integrate it. How's it going to fit in your network? What are the hooks that you need to put it in place? What additional features and functions do you need to develop? What are the APIs that you need to put into place so that it can be managed with the infrastructure you have today? How are you going to install it? How are you going to make the installation fast, without delays, with low overhead? It's very important with this phase to make sure that you work with your operational team because they need to be on board with this. In the past, they might have just had somebody else do it, but now you're doing it. And so they need to be involved. So all these things have to come together. I guess what I'm saying is Radisys has been doing this for customers for some time. We've been planning systems, designing systems, installing systems, testing systems, as well as providing the infrastructure to support the system when it's installed. And that's what we do. So thanks for listening. I appreciate it.